Alright, we're doing a die casting for the brake pedal. My name is Xavier Bland.
I'm Ashton Goldwood.
Alright, the objective was to pretty much make 50 brake pedals for a race car that meets the performance criteria of the material that we chose. It must have a yield strength of 25 KSI or higher, ultimate tensile strength of 35 KSI or higher, and get a mold design and a post-casting process. Alright, what is casting? Casting is a process that goes back almost 1,600 years, and it's basically when you pour a liquid material into a mold which contains a hollow cavity, and then you let it sit to solidify, and you get the material that you design. Casting is one of the oldest known manufacturing techniques. Each different casting process comes with different pros and cons, such as the sand casting. Pros to that is that it's cheap to make but has dimension problems. Invest in casting, it comes out with a good finish, but it's high to actually make the product. And also it's longer production time. Die casting is good finish, good dimensions, but it's also higher to make the product. Die casting. Die casting is pretty much a metal alloy casting. It eliminates or reduces secondary machine operation. Inserts can be cast into the die, and good surface finish and excellent dimensional accuracy. Die casting. This is the die casting process. As you see, you'll pour the molten metal into here, and it will push the molten metal into the cavity, which is powered by pressure. The plunger will push the molten metal into the cavity, and it will set over time. Right here, you'll have your metal cover die that will actually be the cavity hole for the product that you are making. Once the product is done, the ejector die will push back this way, and the ejector pins will actually push the product that you are making out.
And after it comes out, this is what you're gonna have. And we're gonna have a core that's already made that goes right here to make that piece right there. And the rest of this, the rest of it we filled in. That's gonna be part of the post casting process. We're gonna do it with zirconium nitride coated and dosable end mill. It's just one piece. You don't have to keep changing them, so that'll save us money. Also, you can do it all in one step, so we don't have to drill this with another drill bit, and all of it can be done with the same end mill. This pipe will be done, the finish on the edge, and then the curve on the corners. They're all going to be done with the same piece. The material that we use is aluminum alloy. It's lightweight. It's good with corrosion. You can recycle all the pieces, like the little chips and the pieces that you done wrong. You can recycle all of the pieces that you don't use. The material is a better finish with the product that you end up with. It behaves well with heat, and it's strong and good. And this is where we have what the customer asked us to do, and the measurement for what our product ended up being. Our UTS and tensile yield strength ended up exceeding the preferences for the customer. Our ductility and corrosion resistant and hot tear resistant measurements are here. And a summary of our project is weight saving. It ended up being lighter than necessary, and that saves on packaging costs as well. Cost reduction due to elimination of major post-finishing operations, which would be usually you got to change out the parts, and that takes up time to do as well as money to get those parts. The use of the die casting may cost more for production, but we provided a more dimensional accurate product, a rapid production rate, and a higher mechanical strength. So basically, we altered what is usually done to make standard brake pedals. And we changed the material as well, and then ended up better.
Next.